Hello, this is Mr. Stansbury. I'm going to take you through the notes on inverse functions. At the end of this, you should be able to say, I can tell if a function is invertible and I can find the inverse of a function. Okay, so first thing, an inverse operation undoes the operation. Okay, so it's the inverse it's kind of like the opposite. Okay, it's going to undo it. For example, the function y equals 1/2 x plus 3 is undone by its inverse function y equals 2x minus 6. Okay, now these two, this is the inverse function of this, and this is the inverse function of this. Okay, to hopefully better explain that here. To find an inverse of a function, we simply swap the x's and the y's and we solve back for y. Okay, and this is I'm gonna go through some explanation here, and it's gonna come back around and it will start making better sense here in a bit. Okay, so let's say this is the function y equals negative 3x plus 10. Now the inverse of that, we're going to switch the y's are going to turn into x's, and the x's are going to turn into y's, and then we're going to simply solve for this y. Okay, so we get x equals negative 3y plus 10, move the 10 over, so that's x minus 10, and then divide both sides by negative 3, so we get y equals negative x plus 10 all over 3. So this is the inverse function of that function. Okay, now you can check to see that it works. So let's say we start with the original function y equals 3x plus 10 and just plug in any value for x. So let's just say x equals 20. We plug in 20 for x and we get that y equals 50, negative 50, excuse me. Now if this is truly the inverse function of that, if we plug negative 50 in, now instead of the y, we plug it in for the x here, right? Because the x's and the y's swap spots. So we plug negative 50 in for this x, and we should end up getting our 20 back. Okay, so we plug negative 50, so it's negative 50 plus 10, so that's 50 plus 10 over 3 is 60 divided by 3, which is 20, which is indeed what we started with. Okay, so that's an inverse function. Okay, let's see if this makes it hopefully helps a little bit more. Okay, so now here's the line y equals 1/2 x plus 3. That's this pink line here. And then the inverse is y equals 2x minus 6. That's this line right here. Okay, so if you'll notice, this line right here, this red line right down the middle, is the y equals x. And if you'll remember, if this is the inverse of this, we switch the x's and the y's. So, for example, this point right here, this is 2, 4. So if you switch that x and y, it now turns into 4, 2, which magically is this point right here. This point is 0, 3. If you switch those around, that's 3, 0. And look, right there, that's 3, 0. So any one of these x and y coordinates out here that you come up with, if you flip them around, they will be on this inverse graph. Okay, so all the x's turns into y and all the y's turn into x's. Okay, so we just wrote some of that stuff down here. So notice that the inverse is a reflection about the line y equals x. Okay, and notice that some points on the function and its inverse, right? So this is where our x is turned into y, y turns into x, x turns into y, y turns into x. Okay? Okay. All right, next thing we have is one-to-one function. A function is a one-to-one if each y has only one x. These will satisfy a horizontal line test. Okay, so basically we're trying to figure out if a function is a one-to-one function, that means that that the inverse of its function is also a function. Okay, so meaning, okay, let me put this layer on here, and this will hopefully help out. Okay, so if you take this thing here and you reflect it around the line y equals x, the red original line, you end up getting this line here, y. Okay, so this one here passes the vertical line test, right? Sorry, there's no x has more than one y. Okay, so this is a one-to-one, and the reason why is because the inverse is a function, so that means it's invertible. Okay, so now on this one over here, we started with this red one here, And if we do the thing called the horizontal line test, not the vertical line test, but now the horizontal line test, I'll show you here really quick. Okay, so here's our test. So this here, notice that this horizontal line test, there's lots of different points. Like say right here, there's these 2 points are on the same horizontal line. This entire thing is full of like 2 different points all on the same line. Okay, now when we take the inverse here, we take the inverse, that's going to be the inverse of this red is we flipped it over, switches all the x's and the y's. So basically you flip it over the line y equals x and we get this line here, right? So if we go through and we can look at this by doing a vertical line test. We got our vertical line test here, and notice there's lots of different points on here that there's infinite points where there's an x has 2 different y's. Okay, so what we really are saying is on the original one, on the original function, if it has any 2 points on the same horizontal line, because when you flip that over the y equals x line, you're going to get 2 different points on the same vertical line. It won't pass the vertical line test. So this here is not a one-to-one, and the inverse is not a function, so it's not invertible. Okay? Okay. A quick comedy break here.
Driving the other day, and there's a guy in the lane next to me. He's in a convertible. He's talking on a cell phone. I think I'm more important than I really am. And here's why. Just yammering uselessly. So I had to watch what I was doing and what he's doing. And this guy had construction in his lane, so he needed to merge into my lane. He didn't even know this because he's into his call, and I knew he needed to merge. I gave him some room. I swear, here's how he thanked me. He's looking down, he's talking, he looks up, sees the construction, sees that I'm giving him room, and he goes, could less effort possibly be put into thanking a fellow human being? Oh man, here I was all self-absorbed, and you were nice enough to look out for my safety. I don't know how to thank you other than...
Okay. Let's look at this here. Example 13, last one. Consider the graph y equals f of x. So here's our graph y equals f of x. First off, is f of x invertible? Why or why not? So if you want to, let's think of it this way. Let's think of the vertical line test, the horizontal line test. So we're going to take a horizontal line here, run it through the graph. Does it hit 2 points on the same graph at the same time? No, it does not. So that means that yes, it is going to be invertible, because when we take this thing and we reflect it over the y equals x line, or we switch all the x and y coordinates, it's still going to end up being a function. Okay, so here it is. Yes, because it passes the horizontal line test, and a little bit more specific would be yes, because any horizontal line crosses the graph at most once. Okay, sketch a graph of the inverse function. So you can draw the little line and try to reflect it over the line. I'm simply just going to choose, if this is 0, 1, I'm going to switch those two, and now it's 1, 0. So there's my new point. Let's see, this right here is at, let's do this in red. Let's find some nice points here. That looks like a pretty easy point. That looks like that's about a half. We'll do those. We'll invert all of those points there. So again, this one here is at 1, 3. So we switch those around, and it's now 3, 1. This is at -1 and then 1/2. So we switch those around, and that's going to be 1/2, -1. Right, so we get that. And then this is -1, 2, 3, 4, and up just like a quarter. So positive a quarter. So now it's going to be positive a quarter, and then down about 4. So it's going to be about right there. Okay, so then now we just going to sketch our graph here. Oops. Sorry, this is a little trickier here. There we go. Looks something kind of like that. And again, if you picture the y equals x line right here, that's a nice little mirror image. Okay. And then last thing, state the domain and range of both y equals f of x and y equals f to the negative first of x. This here that means inverse. Okay, so y equals f of x. We've got the domain is basically it goes forever and ever to the left and officially goes forever and ever to the right. So the domain is all the real numbers. And then the range, you'll notice this 0, the x-axis is acting as an asymptote here. So that means y is going to be greater than 0. So y has to be greater than, not equal to, because it doesn't look like it's ever going to hit that line there. So y has got to be greater than 0. For the inverse function, y equals f to the negative first of x. Domain, now that's this blue one here, right? So the x's, we can tell right here, it's like, oh, x has to be greater than 0. It goes forever and ever to the right, so x is going to be greater than 0. And then the y goes forever and ever down, and it's still going up, goes forever and ever up, so the range is going to be the real numbers. So if you'll notice, look, these basically, the domains and range just switched. Okay, that's all there is for inverse functions. If you have any further questions, please feel free to ask. Thanks.